Good evening, guys. This is Mr. Holmes getting ready to talk to you guys about how to add rational expressions. Now, when we're adding rational expressions, we're going to start off with like denominators here. So here, let me just put like denominators. When you have rational expressions and the denominators are the same, like denominators, you simply add the numerators and keep the denominators the same. Do not raise anything to a power, do not multiply, just keep them as is. My denominator is 2g, so here I'm going to have 2g here as part of my final answer. And I'm going to simply add my numerators, in this case 3 plus 4, and it's going to give me 7. If these two numbers 2 and 7 were divisible, meaning they can divide, if 2 can divide 7 evenly or they were able to be reduced, we must divide or reduce. In this case, we cannot, so 7 over 2g will be considered our final answer. Now, still in the subject of adding rational expressions, we're going to try this time with unlike denominators. Now, this is where the bulk of adding and subtracting rational functions with unlike denominators. This is where there's multiple methods to use, and it's here for the most part. As long as you find the LCD, that's one method, which is the least common denominator, or we can use the cross multiplication method. I'm going to show you guys both methods. You choose the method that works best for you. All right. So let me just find one here at random and we're going to get to work. So here we are. I have one here. I'm going to use 12. Let me not write in red here. It's going to be 12 over x squared plus 5x minus 24 plus 3 over x minus 3. Now, I know what some of you guys probably thinking, wait a minute, this looks a whole lot different from the first rational expression that he showed us. Yes, it is. Because what I try to teach for the most part is conceptual. The concept in the beginning, as long as the denominators are alike, you can simply add the two rational expressions. In this case, the first step you must do here is simplify by factoring out both numerator and denominator if possible. Alright, so what I'm going to do here is I'm going to go ahead and factor my denominator here. There's nothing to factor in either numerator or the denominator here. However, in this denominator, I can factor this out. Alright, so what I'm going to do is I'm going to factor it out. I'm going to have over here 12 over, because this is a standard trinomial, I'm going to open up two sets of parentheses, and when I say standard, I mean the coefficient of x squared is being 1. So that being the case, I can open up two sets of parentheses because it's factorable and put an x in each set of parentheses. Then I think, what are two numbers that will multiply to give me a negative 24? But when I add those same two numbers, I will get a negative 5. In this case here, I mean a positive 5. In this case here, it would be a positive 8 and a negative 3. When I multiply 8 times negative 3, I will get a negative 24. If I was to add 8 and negative 3, I will get a positive 5. That being the case, positive 8 and negative 3 are the two factors of negative 24 that will also add to give me 5. Here, there's nothing to factor out, so I will leave it as is. This is said to be simplified as of right now. Now, from here, some people will think, well, you know, this looks like it's going to be kind of hard, and it's really not. We need both denominators to be exactly the same in order to add. Both denominators share x minus 3. However, the denominator to the left have x plus 8, where the denominator to the right does not. If we can get this x plus 8 in this denominator, we wouldn't have no problem at all with simply adding the numerators. In order to do this, I would simply, and I'm going to just move up to show you, I'm going to rewrite all of this first so I'm not doing too many steps at one time. Now, some of you guys may not do this. Some of you guys may go ahead and do what I'm about to do now up here. But again, this is for teaching purposes to help you guys understand. What I'm going to do now is I'm going to actually take the time and multiply my fraction here by what it does not have from my denominator over here. In my denominator, I do not have x plus 3 over here, but it is right here. So I'm going to multiply this fraction by x plus 8. Again, the reason I'm doing that is because I need it in this denominator. So here I'm going to do x plus 8 over itself. And the reason we do it over itself is because anything divides itself one time. So we ultimately we are multiplying this fraction by 1, and we do not change the value of the original fraction. But in doing this here, we will keep my first fraction exactly the same. I have as, and I'm going to move this up some more, 12 over x plus 8 over x minus 3 plus my denominators. When multiplying, I am not going to actually combine the like terms. I'm not going to actually multiply. Distribute or distribute. What I'm going to actually do is just simply multiply. I'm going to end up with x minus 3 over x plus 8. In my numerator, however, I must simplify. So here I'm going to distribute this 3 into this set of parentheses. I'm going to multiply 3 times x, and I'm going to get 3x plus 3 times 8, and this is how I get my 24. What I want you to notice now is that both denominators are exactly the same. And because both denominators are exactly the same, we can go on ahead and add the numerators. So in doing so, we're going to combine any terms that are alike. So here I have 12 plus 3x plus 24. So I can combine my 12 with my 24. Those are like terms. And I'll be left with simply 3x plus 36 all over x plus 8 times x minus 3. Now we are completely done with this polynomial. However, to check just to make sure that we don't have any common factors, which I know we don't personally, but I'll show you anyway. Here we can try by factoring out 3 out of both terms in my numerator. Since it's factorable, we can factor out 3, and we'll be simply left with x plus 12 over x plus 8 times x minus 3. Again, it's very important to factor out in the end just to look for common factors. If you have common factors, you must divide them out. But in this case, we did not. So here we are, guys. We started off with trying to add 2 rational functions with unlike denominators. In doing so, we factored out as much as possible in the numerator and the denominator. In this case, we only had to factor out the denominator of one of the rational expressions. We recognize in this step that, hey, this denominator does not have an x plus 8. So in order to get it, we must multiply by what it does not have over itself. X plus 8 divided by x plus 8. From here to here, we simply distributed that 3 into the x plus 8, and we simply multiply without actually combining any like terms in my denominator. From this step to this step, all we did was went on ahead and combined like terms because denominators are exactly the same. The 3x stood here, and we added 12 to 24. That's how we got 36. We could have stopped here, but I wanted to show you guys once we factored out that there were no common factors, so it's already said to be in its simplified form. There you have it, guys. This has been Mr. Holmes explaining how to add rational expressions with like and unlike denominators. And if you know Mr. Holmes, you know what I'll say. I hope you enjoyed this video and have a blessed day.